This is an avionics bay for a model rocket, and you're about to see how and why I made it. It's been a while, and I'm working on a rocket that can fly and land safely using random things lying around my house. This is my first rocket build, which means I have zero experience in this. And zero experience means lots of experiments and stupid mistakes. I'll take you on a little trip so I can explain what I've done and what still needs to be done. I'll tell you about the simple mistakes I made while building the avionics bay and while handling batteries. I'll also talk about a topic that isn't related to my content, but is important to talk about because it concerns everyone's health. Before starting work on the avionics bay, I completed the fin can by adding a cardboard cap on top so the rocket motor doesn't stick out of the motor mount. For that, I used a cardboard base that is normally used to place cakes on, but I'm giving it a chance to fly. After that, I added a sleeve to the fin can using PVC cement and super glue to attach it to the rocket body. The sleeve length is a little long, but it will be cut down later. To make it stronger, I added a few screws with some wood glue, and it was looking very strong. The fin can was done, so now it was time to work on the avionics bay. And I did what every good builder does before starting: planning. I designed every part on paper to understand what I had to do. On paper, because using my laptop would be more accurate but time-consuming. And I don't know how to use 3D software, that's why paper. This is how not to fix a water heater. Just take a screwdriver and open everything you see on the heater. Screws, electronics, connectors, pipes, everything that can be detached. Make sure you do it carefully so you don't damage the heater. After opening everything, look for things that are useful. Like in my case, those connectors were very useful because I can use them in my flight computer instead of using header pins that can detach during flight. I always wanted to open random electronic stuff lying around my house, but it was impossible when I was a kid. And now it's a small and fun thing to do. Anyone who had an interest in machines since childhood can understand me. I took out those connectors and some more parts that might be useful in the future, and they will be used in my avionics bay. To make the base of everything, I used a piece of plywood as I had drawn on paper, and I cut it from the same plywood that was used for the fins. After some sanding, it was ready and in the perfect size. This is my design of the avionics bay, and there are two PVC parts that will help it fit inside the rocket body. So I cut two identical pieces from a PVC pipe that has the same diameter as the rocket body tube. To mount a LiPo in the back, I used this metal piece that I found inside the water heater. Using a wood screw, I attached that piece to the plywood. When I tried to mount silly on the plywood, I noticed that the small screws I had couldn't do the job because they are kids right now, and I can't wait for them to grow. So I cut some small plywood pieces and attached them to the base so I can mount silly using those tiny screws. It doesn't look good, but it should work just fine. That fix worked, and I mounted silly to the base with those little screws and some super glue. Just behind silly is the battery mount, and a LiPo or any other type of battery can be attached to it, as you can see here. It's a little different from my paper drawing, but that's how DIY works. Everything gets better with time and experience. I tried to add a layer of foam between silly and the plywood, but it didn't work. Always make sure to use gloves if you don't want super glue stuck on your fingers, and always pay attention when handling LiPo batteries. I didn't handle it carefully and somehow touched both plus and minus together. I don't know how, but this LiPo is still working, although it gave lots of smoke at the point where I made that stupid mistake. After all, my 400 rupees got saved by luck. The connector on the LiPo was not good for high vibration environments like inside a rocket. So I replaced it with better connectors that I found inside that water heater. A male connector is on the LiPo, and a female connector is on Silly's power pins. These connectors are a little too big, but they are very reliable for a flight computer. All the connections have been done, and about 70% of the avionics bay is completed. The design is very simple and easy to make, but I had to compromise on looks. After all, who's going to look inside the rocket? Attaching those PVC sliders was a little hard because they didn't stick with super glue. I put the avionics bay inside the PVC pipe and then attached them, but I got stuck with the pipe, so it took a little while to remove it. Now it's ready and can be easily placed inside the rocket body, but I wasn't able to place the PVC sliders at the perfect positions. However, it's fine. The joint was strong, but I couldn't leave it like that, so I added some epoxy to the joints. I had just enough epoxy to make fillets. It's hard to work with 5-minute epoxy, but this is what I can buy nearby, so it's the only option. Now let's talk about something very important that is not related to my content, but is related to our health. If you are living in North India, then you already know about the problem. And if you don't live in North India, then you are very lucky because the AQI here is extremely high and just keeps on growing. Unfortunately, I live in the most air-polluted nation, near one of the most air-polluted cities. It's not just about a few cities. Just look at my motherland. I mean our motherland. It's burning to death. Just imagine the kids who live in this hell and the old people who just want to live a little longer. Everything is already polluted. Our air, our water, our forests, and our land. I remember when I used to help my grandfather grow vegetables on a small piece of farmland. We found nothing but lots of plastic underneath the surface of the soil. Well, it all can be fixed. But the worst thing is that our government is doing nothing about it. They are all sitting in their rooms with air purifiers. They show up only when they want votes, and we are all stupid enough to fall for the government's game every time. Subscribe to me so I can contribute to changing the situation in my motherland. If it doesn't go as planned, then there are more good places around the world. You know what I mean? Anyway, back to the main topic now. I marked the points where I needed to make screw holes, and using a hot needle, I made the holes. During this, the flight computer was inside, so I could make all the screw holes at the same time. I forgot to tell you about this plywood cap, so I'll explain it now. The cap will hold the parachute and the ejection charge. It will not be glued to anything in the rocket. It will be a free part. I designed it this way so it will be easy to pack everything without adding any more cuts to the main body tube. There is a little PVC piece inside that will stop the cap from coming out, and the whole rocket will hang on it with the parachute. Before assembling everything, I tested Silly and it was all fine. I used a small light bulb to simulate the igniter, and 2 more connectors are added for easy connection between the igniter and Silly. As you can see, I can just put the igniter in and slide the flight computer inside the rocket body, and then secure it all using 4 screws. Right now everything looks a little dirty, but I will make it beautiful with a paint job. The weight of the rocket is around 1 kilogram without the nose cone and parachute, and I don't want to go above the 1.4 kilogram mark because I think the motor I will make can produce 2 to 5 kilograms of thrust. So less weight means a faster rocket. I tested this setup a few times and it is working fine, although some little changes still need to be done, like the rocket body and fin conjoint not being perfect. That's it for this video, and thanks for your time. Follow me on Instagram if you want early updates on my project. See you in the next video. Have freedom.